Okay, this is our last section of trig evaluating functions with degrees. We will be working on radians after this next test, but we've been working with evaluating trig functions of the first quadrant, so using those reference triangles 30, 45, and 60s. Then the other day we said, wait a minute, we could spin around to those other three quadrants, and so then therefore we would draw out our angle, and then we would find our reference angle, kind of bringing it back to that first quadrant. And so we use those all students take calculus. So today what we're going to do is we're going to find angles that are bigger than 360 or less than negative 360, because what we did yesterday or the day before was go all the way around, full turn, full rotation in the positive, or a full rotation backwards. And so now we're going to go past that. And so to go past that, we're going to want to talk about something called a coterminal angles. I may have hinted this at class in one of them, that coterminal angles is that idea that if I ask you to spin or do a 360 or a 720 or a 1080, all you're doing is a circle, because there's 360 degrees in a circle. So I'll make a 1 rotation, 2 rotations, 3 rotations. I seem to be... So what we're going to do is just keep rotating around and around and around. And as an example, if I had an angle here, and we'll call this 30 degrees, I could start at 30 degrees and make a rotation of 360 degrees. It would leave me in the exact same spot as where I started, which would be resulting in a reference angle of 30 degrees. Because I initially, and I'll change colors here, initially I went 30 degrees. And then I went rotated 360. Well, 30 plus 360 is equal to 390 degrees. I'll have a 390 degree angle. That means a 390 degree angle is the same as a 30 degree angle. They're the same. And I could do that again. I could add 360 because I can go around that again. So I'll add another 360. And now I'm at, what, 750? So it'd be 750. So 750, 390, and 30 are all coterminal angles. So coterminal angles all differ by 360. And they say differ by an integer multiples. So 1 times 360, 2 times 360, 3 times 360, 0 times 360 leaves you with the same angle. You can also do -1, -2, -3, which means instead of going in the positive direction by finding a coterminal angle, I can go backwards 360 and end up in the same spot. Hence, if I am at that same 30 degree angle right here, and I subtract 360, I will end up in the exact same spot. So, in this case, 30 minus 360 is a negative 330 degrees. And I will be in the same exact spot. So what's going to be asked of you is I'm going to give you angles, and I am going to want you to find the coterminal angles. So here we got 45 degrees. Now, what I'm going to ask you to do, because a lot of times, or this is going to lead us to, is taking a trig value, a sine, cosine, tangent, of angles that are outside of 360. So the first two, they're not too bad. They are actually within 360 degrees. You would just use your sine, cosine, tangent. But as we start to move out of, like our third problem here, we will then want to bring it into something that we like. So what we're going to do for our exercise on these is to find one positive and one negative coterminal angle, which means if I want to find a positive coterminal angle to 45, I'm going to add 360. Actually, I'm going to add 360 to all of these until I find a positive angle. So yes, 45 is positive, 236 is positive, but I want to find a coterminal angle that is also positive. So I'm going to go here and put plus 360. And if I add 360, I will end up with 405 degrees. So 405 degrees is a positive coterminal angle. Now I could have added 720 instead because that would be twice around, and I would still end up with a coterminal angle that was positive. You wouldn't be wrong, you would still get it right, but for the most of us, we would say I want to find the most, or not the most, but the closest positive coterminal angle and the closest negative coterminal angle. So if we added to find the positive, then we should probably subtract to get to the negative. Now that's not always going to be the rule, but it's going to be majority of the rule. Because when we get down to that last problem, I'll explain that. So 45 minus 360 should be a negative 315. So negative 315, I found a positive and I found a negative. Get the circle a little better. Positive and a negative coterminal angle. Moving on to 236, I'm going to move to the bottom here. I'm going to take 236 plus 360, and if I do that, doing some quick math, that's 596. So a positive coterminal angle to 236 degrees is 596. Likewise, to find the negative coterminal angle, I'll take 236, and I'm going to subtract 360. And if I subtract 360, I end up with negative 124. I have a positive coterminal and a negative coterminal angle. Now, these do not match up with what we have for our unit circle. I would not ask you at this point to evaluate this and find the exact values. These would be a calculator style problem if I asked you to find the sine, cosine, tangent of 236. They're not one of our reference angles. So now the last one, which is negative 660, I'll move this out of the way a little bit. For negative 660, it's slightly different, as in we're going to want to find a positive coterminal angle, we're going to add 360. That's great. So if I add 360, I do believe we'll end up being at negative 300. And you're like, oh man, that's not a positive coterminal angle. But wait, that ends up being a negative coterminal angle. So this is actually one of your answers. You don't need to subtract. So not every time are you going to both add 360 and subtract 360. You're going to use it to your advantage. So if it's a very large angle, you would subtract 360. One of those subtractions along the way can count as your positive coterminal angle. Make sure you circle it if I'm asking you to find them. Then, on the other side, I still need a positive, so therefore I'm going to add 360 again, and this ends up being 60 degrees. And there is my positive coterminal angle. So you're going to add 360, subtract 360. And that's how you find coterminal angles. Now the thing about coterminal angles, it's great. I'm not going to just ask you to find coterminal angles. Again, I want you to evaluate trig functions of all types. And so that's why we're going to lead to these steps. These steps are, we're going to evaluate trig functions greater than or outside of 360 degrees. So, what I want you guys to do, I want you to find the coterminal angle that is between 0 and 360. It does not actually have to be between 0 and 360. I think it's just easier to work with positive angles than negative angles for most of us. But as we get more familiar and like this a little bit more, we will be able to then extend this side all the way to negative 360 because we'd be okay with drawing the circle and drawing your angle and finding a reference angle. Because that's what it all comes down to anyways, finding a reference angle. So step number 2, find the reference angle. Now remember, to do that, we had steps last time. You graphed it, and then you looked for what angle would it take to get you back to the x-axis, the most immediate one. Once you have that, you're able to change your trig value to its trig value of the angle, or the trig angle to the value angle that is your reference. Make sure we're using all students take calculus, and therefore you can find your positive or negative ratio. So you use those reference triangles, and then you can sub in the ratio value into the expression. So if there's a constant or a coefficient or multiple trig functions chained together, you basically replace the trig function with its ratio value. So here we go. We're going to start off nice and easy here. First one up is sine of 630 degrees. So this is what I would like you guys to do. So number one, we need to find our coterminal angle. So I'm going to break 630 out by itself. And since 630 is bigger than 360, I'm going to subtract 360. So if I subtract 360 from here, I am going to get 270. Now, I'm realizing that I picked the wrong angle because 270, guys, is one of our, not on our unit circle, because if I go to graph this, there's 90, there's 180, and there is 270. And so I'm going to actually leave this one alone because later on, after our next test, we'll be talking about these angles at our 0, 190, 180, and 270. So right now, let's ignore that. Other than the fact, let's talk about then that the sine of 630 is the same thing as sine of 270 degrees. So that was a good practice there. They're coterminal angles, which means they have the same trig value. Okay, the next one should work out better. So, cosine of negative 480. So I break negative 480 out. Since negative 480 is less than 0, I'm going to add 360. And if I add 360, I do believe this will be a negative 120. And some of us will be like, hey, we did that just the other day. I did cosine of negative 120. I could graph that and find my reference angle. Yes, yes you can. My other suggestion would be to keep going and get this to be a positive angle. Add 360. So you end up with 240 degrees. Because that means that cosine of negative 480 is the same thing as cosine of negative 120. Which equals the cosine of 240. So all three of them are the same value. It's the same sine and the same ratio. So now at cosine of 240, now we can do our graphing. 240 is 90, 180, 240, so it's down here. Make your triangle. And you're like, if this is 240 degrees, what would be the angle left over after kind of, or maybe going back to the x-axis? And I'm hoping everybody would be, hey, that's 60 degrees. So that means it's equal to the cosine of 60. But, according to all students take calculus, it's in the third quadrant. Tangent's the only positive one, so it's actually equal to the negative of cosine of 60. And if you go to your reference triangles, which you should be writing down on your paper, this is the 30, 60, 90 variety. Remember, we always like to put 30 on top, 60 kicked out to the right, so I can go 1, 2, 3, square root. Cosine of 60, 60's there, cosine is adjacent over hypotenuse. So this becomes a negative of 1/2, which is a negative 1/2. And there's your answer. So what does cosine of negative 480 equal? Negative 1/2. What does cosine of negative 120 equal? Negative 1/2. What does a cosine of 240 equal? Negative 1/2. They're all the same because they all terminate in the exact same place. This is a negative 120 degrees. So that's why I could have used the cosine of negative 120. So this is your homework. There are 10 problems. I want no calculator to be used to actually evaluate the trig functions. I will let you use a calculator, I guess, to find the coterminal angles. Every single one of these problems, you will have to add or subtract 360 degrees multiple times, or up to multiple times. That's the only time that you're allowed to use a calculator. So if something comes out to 1 over square root of 2, you better fix it to square root of 2 over 2. If it ends up having square root of 3 over 2, you leave it as square root of 3 over 2. We've done this in class before. So I am not doing separate find coterminal angles on this one because you have to find coterminal angles to do this problem. So I would like you guys to do these 10. And 10, watch out for 10, because not only do you have coefficients in front of something that you have to find coterminal angles of, both of them, you have at the end, have to put them together through addition. So get a common denominator. All right, have a great day.